That was a new message on the recording one, and it wasn't alarmingly loud, so that may be another nice feature with the update. There's Joe. I'll let him in, then we'll get started. Hey, Joe.
Hello.
We were just getting started. I just hit record a second ago. They changed the message whenever it starts recording, so and the volume level of that message when it starts recording, so that part was kind of nice. So got a couple things on tap for today. First off, we're going to finish up the stuff from last week, just some details. I moved, you might remember last Thursday, I moved the example part up, what we actually need for the homework, because, well, most of the people in this class are taking the introduction class at the same time, so we haven't seen a lot of object-oriented programming before, which for PHP isn't a problem, because what we need from object-oriented programming in PHP for the most part to make our job easier is that very first introduction level, very first thing we always get introduced to. So we just do the double up your introduction to it, because that's what we need here. But our textbook was put together for not at the introduction level, so there was probably some confusing points in there. So I wanted to talk about those, and I guess just give a brief description of how that stuff fits together, so it's not completely overwhelming, and when it's not brand new, you'll know how those things fit together. Then we do a short thing with try-catch blocks. We'll see that in a moment. There's an issue I always have with textbooks, and that's that you can't really generalize try-catch as far as proper usage of it. And as a result of that, textbooks always have lousy versions of the try-catch stuff. Not just this book, that's like all books. It happens because you can't generalize try-catch, but a textbook kind of has to. They have to at least show the syntax. But I think I've finally come up with a good example to address that, the little, I guess, pet peeve I have with that in textbooks. We'll talk about that in a moment, because what textbooks have to do in order to generalize it doesn't even fit the criteria of handling an issue. So we'll see that. And then one last thing from last week that there was one other issue with the error handling. I put that off. Well, I intended to put that off. You may have noticed on Thursday, I accidentally quickly threw the big issue. And then I tried to navigate away from it really quick, if you caught that during those couple seconds in the video. But I wanted to wait till y'all saw the big issue before we address that. So it'll only take a couple minutes to address that. It's an easy fix, but I wanted to wait until you saw it. Some of you may not have seen it. If you started working on the programming assignment and put that together in logical order, kind of like we did in class, we didn't put that set error handler until after we got it debugged. So you may not have seen the big issue. Others might have switched your order around, put that error handling in first because it was fresh on your mind, being the last thing we covered in class, in which case there's a good chance you saw the big issue show up. So we'll talk about that. I wanted to wait till, I think I've mentioned it before. I like to see the error messages before fixing them in class, before learning how to fix it in class, instead of trying to predict. I see a comment in the chat room about had to turn it off to fix things. The redirect error, it causes, there is a way that there could be an error that happens in the browser, not this PHP script. So I was going to talk about that today. The good thing about that, I'll go ahead and mention, is that is not something that will inadvertently happen. That is something that will only come from a mistake in your coding. So it will not happen after you finish debugging. But I wanted to wait till everybody had seen the error messages. And that list might have sounded long, but it's a couple talking points, really. So we'll have that finished before the break. And then after the break, we're moving on into MySQL stuff and using relational databases to store our data instead of text files. There's a lot of advantages over that. So we'll see that. But first off, finishing up the stuff from last week. Does anybody have any questions as we get started? Okay, so I assume the silence means no questions. So just a few talking points that really we won't need for our assignment here. But as you move forward in programming, you might want to keep these things in the back of your mind. It's points you're going to hear over and over again. They always, all the parts of object-oriented programming, but our textbook was written for people that probably had a little experience with object-oriented programming. So I wanted to make sure it wasn't too confusing. And I came up with an example that'll hopefully make the reason for all this stuff make sense. That's probably the biggest confusion is you can see the syntax and type that syntax up with no problem, but the reason for it probably doesn't make a lick of sense from what the textbook was showing us. So we saw encapsulation. That's the big one we need. Next one of our key concepts in object-oriented programming from that list the other day was inheritance. There's something called the open-close principle. And if anyone's moving on after this to a 4-year computer science degree, you'll hear that that one a lot, the open-close principle. And the idea is that objects are open for expansion, but closed for modification. Open for expansion, that's where our inheritance fits in. And closed for modification, that's encapsulation. That's what we were looking at in detail last week. So once we finish designing our class, putting that blueprint together, we seal it up. And to use the blueprint example, right? We put the blueprint on paper and then maybe laminate it so that we can't change what's written on that original blueprint. It's sealed up, it's closed. But there might be some other stuff we want to it. So for that, we have inheritance. And it's basically the ability of an encapsulated object to pass on everything it has. Typically to be expanded with more details, to add methods, add some more data fields, sometimes just for naming purposes, just to give the generic class a more detailed name that fits our purpose. But usually to expand it. We'll get everything the parents have and then do something different. So I guess a quick example on that, just something to visualize, is we had that last week. We kind of encapsulated our page, right? We had the links over here, and all this stuff was the same everywhere on the site. So we encapsulated that into our generic page object so that all our pages would be the same. Well, one of the ideas that I originally had for the programming assignments, it may get stripped back, is the site administrator needs more features than the average user. They might need a way to edit the reviews section or directly access the database with a nice form set up specifically for the site database instead of that generic, instead of a generic overwhelming one that has all the features of a database. So the site administrator would need might need a couple more links than the average user. So what my plan was for that is we had our page object. Had some data fields in there. I guess the links is the important one. And then we had some methods down here. One of those methods was make nav, where we'd make the nav section. And another one is make page. Well, that thing we had worked for all the pages, for all the users, except the site admin, because we want our site admin to have a couple more links. We want them to have, I'll try to draw it in a different color, a couple extra links to do that site administrative stuff. So in that case, we could make a child of that inherits everything about the page object. I'll call it admin page, just making up a name for that. And in this case, we could redefine what links are. And since I'm kind of restricted for room here on the board, I'm just going to write plus plus. So links plus a little bit more, because we want those extra couple links for the site admin. And then it gets everything else, and then we can override that make nav section, or that make nav method, so that this child page has makes a different navigation bar, makes a different collection of links than the original one. And we call that override. Word you've probably heard in movies, like the most misused word in Hollywood. Override means change the default. So we inherited everything it means to be a page. And so we took all of that stuff, but then changed only the two things. Just did a little bit of expansion on the two things that we need different for that special kind of a page. And that's the idea of an inheritance. It still has all the other stuff, but it would have a couple more links on the page because from overriding the default one. But it kind of gets we get all the generic stuff, and just like a parent-child relationship, in typical America, parents are going to spend the lifetime, a working career, saving up money, hopefully saving up money, accumulating a few things, and eventually their children are going to inherit that and add to it. Then they're going to work their lives away and add to what they inherited from the parents. So same thing with objects. It gets everything from the parent. The child gets everything from the parent and then expands on it, just to fit our needs. And there's a lot of the stuff about fitting the needs. The next concept, I brought some props in here to show the next concept. Does everybody know what this is? Everybody's seen these before, right? Just some pliers. A very common tool in America, right? It's used to grab stuff, usually when we need to turn it, but grab stuff tightly. I guess these have a little cutter thing on them as well. Electrical pliers, so they're for crimping. But the tool itself is just two levers put together so that we can squeeze a little bit here and get a lot of pressure over here. And basically a grabbing thing, a tool for grabbing stuff, right? Has everybody seen that, used pliers before? But if this is still in the video, but that's what the tool's for grabbing stuff. But have you ever done this with pliers? Take them in. The nails stuck a nail in the board. The nails stay in there, and that worked, right? Hammered that nail right in, but that's not a hammer. Those are pliers. Has everybody done that before? Kind of familiar with that? Seeing something like that? That's what the other concept, a really big word in object-oriented programming, we always use the technical term for it, that's polymorphism. The pliers aren't a hammer, but they work for a hammer. It's a chunk of steel, so it works fine to drive a nail into a board. And when we put objects together, we can do the same thing. It's the ability of one class to behave as another. in particular, the one we use most often is a child class can always behave as the parent object. So if we had some functions, if we wrote some functions that we're expecting our page object to be passed into them, well, we could also pass in that admin page child class, because that inherited everything it means to be a page. So it is a page, it still counts as that. And that's what little arrow in the diagram shows. That confused me for the longest time, because we talk about that connection with inheritance usually. Admin page inherits from page, but the arrow points the way of polymorphism. So the admin page can behave as a page if we need it to. Yeah, and that's the one we use the most. A child class can always behave as its parent. And the reason we do that is for building frameworks. And that's what our textbook was starting to get into. So the syntax part was probably fine, right? You see that syntax, and yeah, you can retype that, put the curly braces in the right spot. Remember that handful of keywords. But it might not have made a whole lot of sense why we would do that. And it's for making frameworks. And I have an example on the next, at the bottom of the next page gets into an example that'll hopefully make all this make a little more sense, but I'm going to talk about all the parts first. Because well, when we made our page object, we knew everything that was going to go on that page, right? We knew what links were going to go there, what the header was going to look like, what we called the style sheet, and we knew all those details. So we were able to fill out the whole class, make the whole thing. But sometimes, especially when we're making frameworks, and by framework, I mean tools to work with later, tools that kind of fill that purpose, but they don't have any details. They're ready for the details to be added. When we get to the example on the next page of my notes, it'll hopefully make a little more sense what I'm talking about there. But when we put those frameworks and start putting plans together, we don't know all the details, might not know enough to fill it in. But we know we'll have some stuff. Another very common example, one of the standard examples to start out with, is shape objects. And when we make a shape, we have some mathematical geometry that we know is going to happen. In particular, well, if there's a shape, we know that shape has an area to it, right? So that's a function that we're going to want to define a shape object. We'll have a bunch of data fields. One of the objects we know we're going to want about a shape is to find the area. So we'll make a public method called find area. But there's a kind of an issue with this, because shape that's referring to our just general geometry, right? That's not a detailed one. Like, we probably know a bunch of area formulas, but do we know which one to put in here? When we have classes, when we have subclasses of that, we probably would, right? Like, one subclass that's definitely going to be there is we'll have a circle shape, or a triangle shape, a square shape, a hexagon shape. Oh, there's a long list of shapes. We have names. The names get really complicated. Before long, we'll get to, if we started listing them out, we'd get up to decaheptagon. Kind of a mess of a name, but we have lots of names. But for those shapes, we know what area would be. Right? The find area function for our circle would just be pi times radius squared. Or the find area function for our triangle is going to be 1/2 times the base times the height. But those are details. And we won't know we don't know the details until we need to actually use this class. So those can't really go into our framework. In our framework, we have to leave that abstract. In our UML class diagrams, the hashtag is the symbol for abstract. And basically, it just means we have this method. We know we're going to have this method, but we can't fill it out. We can't finish it out until we have details. So we leave it abstract. That's called an abstract class. We can't actually create an instance of it. We have to fill in the details in a child, like that circle one that I erased. The circle is a child of a shape. It inherits everything it means to be a shape, including the find area function. Only once we get in that child class, we can fill that out. And then we can actually instantiate it. So it leaves things unfinished almost. Like we know we're going to have this method, we just don't have the details yet. And that's abstract classes. And then we can do other stuff. We can have other objects or other code that would interact with this and write functions that expect a shape object. And then through polymorphism, any child of the shape, like a circle or a triangle or a square, when we actually know what details we need and build those child classes, that can go into the function that's already made to accept shape, because all the child classes are always polymorphic to the parent. And along with abstract classes, so essentially plugging that into the function, what it is we'll know what methods we need to have in order to interact with other code. In order to write functions to work with any of our shape objects, we can go ahead and write them because we know we'll have a find area by the time we have any details and go to use it, which will hopefully make more sense when I get to an example that you are familiar with here very, very shortly. And we can interact with this even before it's finished with an abstract. And interacting, we're talking about machines. So our technical term for interaction between machines is interfacing. And that's another thing that is a whole lot like abstract classes. The thing with abstract classes is we would probably have some data fields up here too. Like we know we're going to have a data for a side of a shape. We just don't know what that side's going to be. And we can fill in some of that. But sometimes we don't have the data fields either. But we do know what methods we'll need. Or we can skip the abstract part and go ahead and just set up the part we need for the interfacing. Go ahead and say we're going to have a get area method, and then don't write anything else with it. So then if anything wants to use our framework, we put this requirement that it has to have a get area method or it can't use our framework. That's called an interface. And it's often referred to as just a list of rules. So it's like setting up a list of rules that have to be used. Maybe a couple constants, things that we know for certain aren't going to change, but typically just a list of method headers. Just public function find area for us in PHP, and then semicolon instead of curly braces to say a block. Public function, then find area, semicolon, because we're not going to write the block of what that function does until we have details. And we put those together, listed those together in what's called an interface. And it's a list of rules that anything has to follow to work with the code that we've written. Sort of a framework for building stuff. Things have to follow those rules. We won't really see it today, but that's something I often do in try-catch blocks. The very first thing I do is, if there's a framework and interfaces that has to follow is I will try to cast everything. That means change the type. I will try to change the type into that interface. And if it fails, I just exit the program. Won't go any further than that because it didn't meet those requirements for interfacing with the framework. It allows us to know, thought I was going to write something on the board, but I guess not. It allows us to know what will be required in order to interface or interact with all our objects and functions and libraries that we've written ahead of time, getting prepared for stuff. That way we don't have to start from scratch every time. Because when we do stuff ahead of time, we don't really have a clue what the user is going to need when they have those details to fill in. We're just trying to save some work on it. So an example that I think most people in this class are familiar with would be the DOM framework from JavaScript. Right? Everybody seen a little bit of JavaScript? We have the document object model, and that's a framework. When they put that together in 1995, they didn't have a clue what we were going to put on a web page in 2021. Right? When they put the framework together, they didn't know what people, that was in August of 1995. They didn't know what people, they didn't have a clue what people were going to put on a web page in December of 1995. So what they did is they set up interfacing requirements, built interfaces and abstract classes so that if anything wanted to use JavaScript, it had to meet those interface requirements. And the main one for JavaScript is that in order for something to be a document, it has to be HTML. It has to have those markup tags. It has to be a markup language with the opening and closing tags, maybe standalone tags. But in 1995, August of 1995, they went ahead and wrote that requirement. In order for something to interface with JavaScript, it has to have HTML tags, which is a small requirement, right? It's just, okay, this language is only going to interact with HTML stuff. But it allowed them a lot of capabilities because they didn't have a clue what tags we were going to put in there. But once they knew that we were definitely going to put tags in that document, they were able to write things like get element by ID and get elements by tag name, query select all. I think everybody's seen those in JavaScript, right? They wrote those functions to interact with the document. And they knew those would work for us here in 2021 because we agreed to that set of rules they laid down. Those interfacing requirements that in order to be a document, it has to be HTML. And that's what's meant by framework, right? That way, whenever we sit down and want to do some client-side scripting, we don't have to figure out how to parse through our HTML document and retrieve the contents of a particular element. They wrote that for us back in 1995. And as long as we put an element, as long as we follow the regular rules for HTML, they already wrote the code for how to grab that element. That's what's meant by framework. And that's probably what seemed confusing. The book didn't really specify that that's what we're building to. The prediction thing. Getting a lot of work done ahead of time, right? Imagine how much harder JavaScript would be if you had to write a function to go through the HTML document and find the data you want every time, as opposed to having that get element by ID function already written for us. So that's what an interface is. It sets up those rules so that we can write some functions and objects and different things. And then 20 years from now, somebody else can use that code we wrote. And as long as they meet those interface requirements, we know their new detailed code is going to work with the framework we put together. So the book was trying to lead into that, but I felt like they didn't do I felt like they could have done a little bit better job explaining the purpose of all that, instead of just showing purely the syntax and seeming to take for granted that people knew that's what that was building towards. The book also talks about namespace. So namespace takes interfaces and abstraction a step further by allowing us to create alternate versions of the abstraction and interfacing rules. So we can have slightly different interfacing requirements or slightly different abstract classes on the same framework. And that way, whenever somebody needs to use that in the future, they can choose from those slightly different versions to find the one that best fits their needs. So abstraction and interfacing give us a way that we know our code's going to work together. The second prop I brought in today, charge cable for my tablet, right? Have the standard wall outlet thing and a micro USB cable, which this did not come with my tablet. I just grabbed this at Walmart, I think. Grabbed it somewhere, Walmart or Big Lots. I doubt I went to an expensive store for a USB cable, but a standard US wall outlet and micro USB cable, those are like interfacing requirements. Right? Some company was able to make those things and then sell them to me, knowing that that would work with the electrical outlets in my house and my tablet by following the interfacing requirements. So that stuff is kind of a virtual version of that. Getting things set up so that when somebody needs that, like when I needed a charge cable, when my original charge cable broke and I needed a new one, I was able to run to Walmart and just grab a cable off the shelf, and I knew it would work with my tablet because it followed the same interfacing requirements that my tablet did. In PHP, we also have traits, and that takes interfaces a step further. So I mentioned an interface would just have this. The interface just says we have a method called findArea. But sometimes we do know what that method's going to be, right? We don't have to wait until we have the details to write things that will, some of the things we know. And that's what a trait is. A trait is just like an interface, only it has code. Interface only has method headers. A trait has method headers and the block that runs for that method. So basically, if you know you have it, that's when you use an interface. And if you know what it does, that's when you use a trait. And then, yeah, that's getting stuff ready ahead of time. That way you know everything's going to fit together. Think of that charge cable that I pulled up there. It meets interfacing requirements that my tablet also met. So I didn't have to do a whole lot of checking and reading. I didn't have to do a whole lot of research and looking around or figuring out what cable I needed. I just went and grabbed a micro USB cable and I knew it would work with my tablet. So it's the virtual version of that is what all that stuff was building up to. So very, very useful, right? If you're going to make a career out of making web pages, it's probably very useful to have a whole lot of framework built up already. That way, when a client contacts you, all you got to do is pull up your framework, throw in some details, and most of the work is already done. So that's what that stuff's building up to. But again, building frameworks is a little beyond the scope of a language course. So in the project, those doing the associate's degree here, the systems analysis and projects course, when you take a whole semester to work on one project and nothing but that project, then you could do it, then building a framework would be reasonable. Or for 4-year degrees, that's a common term project near the, senior term project, senior thesis, equivalent to senior thesis and other things, is to build an entire framework. So it's a little, building the whole thing is a little beyond the scope of a class where we have a lot of other stuff to cover. But it's a time thing. It's just a time thing. You've seen all the syntax for it's in the book. So as you thought it through, you would be able to put one together, just given enough time to do it. which from some of y'all's schedules this semester, the time for that's definitely not going to happen in this 8-week term, right? Does anybody have any questions about that? Hopefully that cleared up some of what the book was talking about. And those are things you'll hear again and again and again talking about object-oriented programming. So I just wanted to make sure and step through it. That way it's in your mind somewhere, really in the future when you have time. After you finish, all of y'all getting that web development certification, after you get that certification and are working as a web developer, you're going to want to build your own framework. That way you can quickly throw details into that framework and get a job done super quick. You could almost call it your style of building websites. That may be another way to look at it.
Okay, question on that real quick, frameworks and everything. So you're saying, building different frameworks, that's like setting up pages of different architectures. And then some of the styling is done by using different style sheets in concert with it. I mean, so the framework would be like, how many columns and, where your nav is and.
Even more generalized than that. That's starting to get into details, but you're along the right lines there. The framework would be more like you're going to have a nav bar and you're going to have columns, or there's an option for columns. Like go ahead and set up an if-else block that then you can click a checkbox if you want columns, or leave the checkbox unchecked if you don't want columns.
So what you're talking about is actually almost like making a box that you can do it yourself by saying, this is what I want, and click the boxes of what you want it to have and everything, and hit the button and boom.
Leading that way, I said hit the button. If you build an interface for it, yes, hit a button. Otherwise, like think of it like you go to type up all the code like we're doing, but you already wrote half of it. You already wrote 80% of the code. So then all you have to do is, instead of, you're going to have a nav bar, you just have to say where that nav bar needs to go. Feed in the links, and you already have the stuff where it goes. So sort of a generalized thing, kind of just doing a lot of the work ahead of time. Might be the best way to think of it. Think about, while you're waiting for a client to hire you, you're still going to put in a full-time work week. So while you're waiting for a call from a client to hire you, go ahead and write code and fill it up with fill web pages up with lorem ipsum text or something. Is everybody familiar with that? The traditional printing, back in the 1600s or something, 15 or 1600s, one of the very early printers, he wanted just to see what pages look like. He took this Latin text and jumbled it around. Like some of there's still some Latin words, but the first two words are always lorem ipsum, and lorem's not Latin.
Oh, that's the junk that you see on the header text box in Draw.io. You click the header thing, and it's got a heading, and then it's got a bunch of garbage at the bottom, and that's what that is, huh?
Yeah, it's so you can see he used real text and just mixed it up, so it doesn't mean anything anymore. Like lorem was originally delorem. Ipsum's a Latin word, but there's some Latin words, some just nonsense, but it looks like actual words. They're all different lengths, and that way you can see what words will look like on the page. It's like testing the page layouts is what it's for. But it's kind of the version of that. Right? You put the stuff together with a bunch of those, and then when somebody hires you, you take that out, you put the actual web page, the words they want there instead of the lorem ipsum text. That's just the traditional way of like looking at what a page layout is going to look like. Looking at what the words are going to look like on a page. But again, you have the syntax is all in the book. And it's just a thinking thing. Think through what you need, try to generalize it as much as possible, and keep it abstract so that all the details get filled in later. It's not a finished product. It's just 80% of the work, so that when you're ready to make something, You just have to do that last little 20% of details to finish it, to fill out the actual version built from the framework. Yeah, so that was mostly what the book was talking about on that, and I was thinking that's what I was thinking. It might seem a little confusing when you're reading through that, and well, the syntax is straightforward, but it never says why you're doing that stuff, and without knowing why, it kind of makes everything look harder. And if you're only doing one project that way, it kind of does make everything harder. So think about it in the long term, right? You make the framework once, and then for the next 10 years, you can just quickly, like a factory a stamp in a factory, where you can just quickly make out thousands of actual versions of what you need.
So it's sort of like having a basic, you just throw different little parts on it here and there, little modifications. It's
exactly.
like taking a bicycle. I've got a basic frame, but I can change the seat, I can change the handlebar, change the gearing system, I can change the wheels, I can change all kinds of junk.
Exactly, that is a great example of it.
But it's still built off the same basic bicycle.
Yes. Yeah. So it's building that basic one that you can detail later and customize later. So the other chapter from last week, were there any other questions? Okay, so the other chapter from last week was exception handling. As you're well aware, things can go wrong when we're programming. Syntax, logic errors, we hit those in development. Release or runtime, there might be often bad input from a user, or we might depend on data written in a file. That stuff we looked at last week, that heavily depended on data in a file, right? But files can get moved or deleted. Things can go wrong with that. So we don't want our program to crash because the file got moved or the file got deleted, or because that's something we could fix. And some of them are major issues from which there is no recovery. And that's what an error is. An error is there's no recovery. There's just little hiccups that we can fix and move on, or at least work around, throw a patch on and work around. And that's an exception. So I like to refer to a boat. An exception is like a little hole, maybe a little bit of water's trickling in between seams. We're in a boat, obviously things are going to get wet. That's no big deal. It's the sort of stuff that a couple towels can handle. But an error that's like the boat hit an iceberg. There's no recovery. The boat hit an iceberg and ripped clean in half. So for errors, there's no recovery, but exceptions, we can deal with those. And that's what's known as exception handling. In a lot of languages, we have try-catch blocks ready to go. We just say try-catch around anything, and it's going to go ahead and work with that. PHP, it's kind of in part because it's running on a different machine. Right? PHP is running off on a server somewhere across the internet. We might not even know exactly where in the world it's running at. But it's a different machine than the client where we're looking at this at. So when errors and exceptions happen, we don't learn about them on the client until long after they happened on that server, and then the results got transmitted to us, which makes it a little harder to build it into the language. So PHP is really just, it's ready for us to build try-catch into it as we need it. And we looked a little bit about errors, redirecting those so that the user doesn't see that message. That will handle most of our errors, our warnings. I put it off till today. I did accidentally throw it in class the other day and then tried to quickly go away from the page, but y'all might have noticed. So I wanted to wait till we saw the error, but there is also fatal error from which there is no recovery, period. In a fatal error, though, that means you did something wrong in the code. So fatal errors aren't going to happen after you finish debugging. You will catch all of those when debugging. Most of our stuff, we can just redirect it in PHP, show the user that nice apology message, send it to a text file where we can log it and deal with it later without anybody panicking. And yeah, it's usually directly related to object-oriented programming. And so for the most part, we have to define our own exceptions. Again, there's a parent class called exception. I'll go ahead and write this whole thing up here. And in exception, we have a couple things we can work with. Where to put them in my notes. We have message, string, code, file, line, trace, and previous. And we also have methods that are get all of these things. So like get message, get string, get line. They come in this order if we need them. But there's some sort of actual message about that code. There's a line it happened on. There's what file it was read from. We have these things to work with. And typically what we do is make a child of that. So like our exception that will handle our particular needs and fix what went wrong for us. And it's sort of a three-step process. We create a subclass of this that gets us a nice, is expecting to catch all of the errors that we expect might happen in our code. So some subclass of exception, or we can catch exception itself and just deal with it right in the catch block. That's what I usually do. Then we have our objects throw our custom exception or throw exception itself, because every exception that exists, even the few that are built into PHP, are subclasses of this. So we know if we catch exception, it's going to catch everything, because anything that goes wrong has to be a subclass of that. And then we surround that code in a try, catch, finally block. So try is what we want to happen. That's our basic code. And I have an example that I think will help make this make sense in a moment. Catch is what to do if that code we wanted to run doesn't work. And finally is code that happens no matter what. The book has some good syntax for that. The thing I wanted to write and so the basic syntax, the word try, and then inside of that is what I put here, code we want to run. I don't know why I had to check my notes for that. And whatever we want to happen, we put in a try block. But there could be an exception. So then we put in the keyword catch and say which exception we're expecting to catch and give it some sort of reference name. Essentially stick it in a variable. And we can do lots of them. We can make a dozen different subclasses and handle everything we expect to go wrong separately and do a whole bunch of catches at once. A whole, sort of like if, else, else if, else if, else if, else if. We can do a whole bunch of catches. I'm just going to do one for the syntax here, just catch any exception. And then this is the part that textbooks really bother me about. And our textbook's pretty bad about it, but all textbooks. I I have not ever seen one that I am happy with what they do in the catch block. Because our textbook is really bad about it, because what did they do every time they got to the catch block in the example? Anybody remember that from the reading? Every single example in our textbook, basically they did this, right? Just echoed a message that something went wrong. But if you think about what happens if we don't put a try-catch block, if we don't put a try-catch block, we get a message that something went wrong. So that's the exact opposite of handling the error. So textbooks kind of have to do that because they got to cover the syntax, but it is virtually impossible to generalize a try-catch block, because the catch is always distinct and unique to the program that you're writing. We need the details in order to handle. We can't handle the error without details. So thing I wanted to specify here, do not send message. Because sending a message is what happens if we don't do any exception handling. So if you send a message, then that's the exact opposite of handling. What handling is, so the do, fix, or patch enough to keep running. Because when we send, that's like sending a message saying something went wrong, and then the program stops. That's not handling the exception. Handling the exception is fixing it entirely, or putting a Band-Aid on it so that the program keeps going. So you want to put something in here that is enough to keep it going. And I think I came up with a good example to help explain this, to help this make what I was saying there make a little more sense. So I'm going to share the screen. Yeah, so basically I just wrote the syntax, and do not send a message. That's not handling an exception. So I share the screen. Pull up our class examples. Or yeah, the in-class example, the one from last week is probably enough. There's something I need to fix if we can get to it before 2:20. It'll take about 4 minutes, is what I'm estimating. But you'll have probably noticed I keep misjudging the amount of time these lectures are going to take. I put them together in getting ready for fall 2019 semester, and then only 3 people signed up for the class, so it didn't run at that time. And a couple times I've been a little bit off on my estimate of how long it's going to take to run. So this is the one we did the other day with the objects. And for example, this order form. If I click here, all of this was stored in a text file, right? It's in a text file that want to read that text file in, and our website depends on that text file being there and us being able to read it. So what happens if that's not there? I'll go in here and I'll make a new folder. A new folder button, yeah. I'm gonna call this try catch. And in this folder, I'll go ahead and set up a quick example. So we have this PHP script which I need a name for. What's a good name? I guess I could call it handle. That's what it's looking at. We're going to actually handle an error and just instead of just sending a message that says something went wrong. So for our class examples and this try catch, have this script handle.php. And so I pulled up this one. I'm going to use this example. This web page depends on being able to read the HTML to set up this form from an external file. So let's do that in the handle. And notice that that external file is not here. Put it here just to make sure that wouldn't work. So we've seen file reading and writing files. So you can create a file handler. I'll call it from file. That needs to read order form .html. We're going to read it and then just echo it back to the screen. Fread, whatever the from file handler can see, and it's not very long, so read to the file size of order form .html. And then close that. Close the handler. So all that looks familiar, right? We've seen reading and writing files, and we saw the other day where our page depends on the data in an external file. Now, if I go over to that other one, what's going to happen when I try to open up that try to run that script I just wrote? I'm going to get a problem, right? It says fopen, failed to open stream, no such file or directory. So we got a no such file error, basically. So the problem was that file didn't exist. That's something that might happen occasionally if our application completely depends on an external file. On servers, not as much. But if you're writing applications that are going to go on somebody's client, that can be a big deal, right? They might just start randomly deleting things that they don't know what it is to make room for vacation photos. And then delete the stuff that your software depends on. So that's something we can handle though, right? So what I'm going to do is I'm going to write this in wrap this in a try catch block. And I'm just going to do the overwriting exception. An exception, only instead of sending back a message, y'all can see on the browser behind it, that's what happened when it was unhandled. I'm going to make sure this throws an exception. So on that reading thing, I'm going to put that in an if block. Which might look a little bit strange because usually we put conditions and Booleans. It's getting a little more detailed, but essentially what a computer only checks false. And we always say true or false, but really a computer is computers only check false. And if this line runs without throwing this error right here, then that is not false, right? If it throws that error, then that line becomes false. So in a sense, that is a Boolean still. It is a true false thing. I could talk about that at length, but it is getting detailed into how machines work and maybe starts to get into a little electricity. Hopefully that makes sense. It's not a Boolean like we're used to seeing, but there is definitely a success or failure. So instead of true or false, we can put a success or failure thing in an if block. So if we can create a file handler, which means we found the file, then we'll read from it and echo the results back to the screen. But if that doesn't work, then I'm going to throw a new exception. So I'll create an instance of the exception object and throw that, which means that the try part failed, so we'll jump in the catch block. And then I want to deal with that catch block. Well, anybody have a thought on what a good way to fix this would be? What I'm going to actually do here is probably more than you expect. Probably a little bit bigger than you expect. Because handling exceptions, we end up with a lot of stuff in the catch block when we actually handle them. And that's what's always off in textbooks. Textbooks are like, okay, echo back the message that it didn't work, which isn't really handling the problem.
Well, if you could find the file somewhere else, you'd use it. If you
that's right along the lines of what I was going to do. So what's a quick way to do this? So here's the data we need. I just went to where it was. So it couldn't find the file, so I need a way to get this data in there. So what I'm going to do is if it can't find the file, I'm going to write that file. That way it can find it. Because hopefully we'll never go into catch block. But if we ever go in there, we want that file to be there the next time the page gets opened, right? So if it's not there, I'm going to write the file. So for this one has lots of bookmarks, so I'm going to do something it's going to make some of what we saw the other day look nice. I'm going to copy all that. And first off, I'm going to paste it in a blank thing here. And then close the original. And we need escape sequences on all those quote marks, right? In order to pass it in as a string so that we can write it to a file. So with it here in the text editor, I'm just going to hit Control H and use the find and replace. So find any quotation mark that's in here, double quotes, because that's what I used when I wrote it, maybe single quotes as well, and replace with the backslash quotation mark. So any quotation marks, double quotes are going to get replaced with backslash quote. And just hit replace all. So now I have escape sequences in all those. Makes it nice and ready to use. So if I select all that, copy it, then over here in that catch, so if the file's not there, I'm going to create a variable called content where I paste all that in as a string. That looks a little messy there at the end. I'll put it at the end of that line. So as one big long string, I got all that content. And then I'm going to write that to a file. To file equals f open, and I'm going to write it to this file that couldn't be found. And that way, hopefully, if it ever goes into that catch block even once, it will write the file and never go into that catch block again because the file will exist after that. And that's actually handling that issue. It's not going to be an issue anymore because now, if it doesn't exist, then we'll write it, and then it will exist. Then fwrite, I want to use that toFile handler to write that variable content where I just put that big long string at. Then I'll close this. Close that toFile file handler. and then I'm going to reload the page so that it reads, so that the file is there and it'll be able to read it on the next reload. And we saw this before, to go to a different page. There's a quick way to do it, but to make it easier to remember, I always do the same thing as going to a different page and just put in the address of the page I'm on. Does that make sense? So, because hopefully we're never going to go into that catch block. But if we do, we're going to fix that issue that sent us there so that we never will again. And then we'll reload the page and try again. So if I look at over here where I stored that file and try catch, the only thing in there is the handle.php script. I save everything. I think so. I'll close this. Yeah, and to put all those escape sequences in, I just copied the string somewhere where there was nothing else and hit Control-H and did the find and replace all at once, instead of going through and manually typing them. Now if I come back over to the browser and reload that page, we'll get that form. And notice it is still handle.php. There's no error messages anywhere that would alarm the user. And if we look over here, that file has now been written. So since our script depended on that file, we don't have to worry about that catch block again, because now the file exists. And that's what you want to do with try catch blocks. The textbook kind of slacked off that. So really, whenever you kind of have to know, textbooks have to slack it, can't do that because you have to have the details in order to write a catch. But your catch block will end up being huge, and hopefully it's a huge section of code that will never run. Right? Hopefully we never have to write that file because we couldn't find it. Hopefully we just find it to begin with. But just in case we don't, we'll go ahead and write it. Does that make sense? It seemed more useful than just echoing a message back than echoing a message back that says something went wrong. Like if we know that's an issue that could go wrong, we can fix it. Hopefully that makes a lot of sense. Fix it if you can. If you can't fully fix it, like we just fixed that entirely. It couldn't find the file, so we wrote the file, and now we know that that file is where it's supposed to be, so the issue's fixed. But if you can, at least put a Band-Aid on it, patch it up, so that you can keep going, that your program doesn't just stop. So that takes a little bit of practice, but I wanted to go over that because textbooks always seem to feel like they really drop the ball on try-catch stuff. So that was the rest of the lecture notes from last week. And yeah, I've made some more notes in there talking about how long it took to give those lectures so that I can edit them down, and next time I teach the class not be quite so confused. Does anybody have any questions about that? Hopefully that helped clear it up a little. Okay, so if there's no questions, we're ready to move on to the second half of the course. So far we've been storing our data in text files, which is kind of nice if it's like that form we just looked at, where we need all the data, the whole data, every time in the same order. Files are great for that. But sometimes we don't need all the data. We just need bits and pieces. If we need bits and pieces, putting that in a text file means we have to parse through the string after we get it back from the text file. And that can be a headache at times. And so an alternative is to use relational databases. So that's what's next, MySQL stuff. So we'll review MySQL, but I think first we should probably take a break, right? You're ready for your 10 minutes? Does that sound good?
If you're waiting for somebody to say yes, yes.
Okay, yeah, so let's take 10 minutes, 2:11, that's probably gonna roll. So we'll start back at 2:22. When the clock's all twos, we'll start back. And I'm gonna go grab me some coffee.